Imagine being able to see a star that existed when the universe was just a mere 900 million years old, a staggering 12.9 billion years ago. This is precisely what NASA's Hubble Space Telescope achieved in 2022, discovering the farthest and earliest star ever seen, dubbed Earendel, which translates to morning star in Old English. But here's where it gets fascinating. A new study suggests that Earendel might not be a single star, as initially thought, but rather a star cluster, comprising a collection of stars. This revelation has sparked a debate among astronomers, leaving us wondering, what if our understanding of this ancient star is not entirely accurate? The discovery of Earendel was made possible by a phenomenon known as gravitational lensing, where a massive galaxy cluster in the foreground of the telescope's view magnifies and bends light beyond it, allowing us to see objects that would otherwise be too distant to detect. This effect is often illustrated using the analogy of a bowling ball on a trampoline, representing the warping of space-time. The Hubble Space Telescope detected Earendel through this gravitational lensing effect, with the massive galaxy cluster WHL 0137-08 acting as a colossal magnifying glass in the sky. The light from Earendel's incredibly distant galaxy, the Sunrise Arc, was magnified, enabling scientists to see it as it was 12.9 billion years ago. However, due to the universe's expansion, the Sunrise Arc is now estimated to be a staggering 28 billion light-years away from Earth. The James Webb Space Telescope, with its larger mirror and ability to collect light at longer infrared wavelengths, was used to follow up on the discovery, and scientists were surprised to potentially spot a companion star. But the new study, published in the astrophysical journal Letters, proposes that Earendel might be a star cluster, rather than a single star or close pair. The researchers analyzed previous Webb telescope data using computer models and found a compelling case for Earendel being a star cluster. Massimo Pasquale, who led the research, shared his secret hope that Earendel is an individual star, but the data suggests otherwise. The study compared Earendel to a widely acknowledged star cluster in the same galaxy, known as 1b, and found similar features, including their age, lack of heavy elements, and resemblance to nearby ancient star clusters. While the new paper doesn't definitively prove that Earendel is a star cluster, it adds to the ongoing discourse, leaving astronomers to ponder the possibility. One way to determine whether Earendel is a lone star or a star cluster is to monitor its light for flickers, which could indicate the presence of a single star. However, securing telescope time for such research would be expensive. The scientific community is now left to consider the implications of Earendel being a star cluster, and we're forced to ask, what does this mean for our understanding of the ancient universe? As Pascal noted, the chance alignment of Earendel with the foreground galaxy cluster would have to be an incredible stroke of luck if it were a single star. But if it's a star cluster, that chance alignment doesn't have to be quite as perfect. The mass of such a cluster could be equal to that of hundreds of thousands of suns or more. The debate surrounding Earendel's nature is a reminder that there's still so much to uncover about the universe, and we're invited to join the conversation. Do you think Earendel is a single star or a star cluster? Share your thoughts and let's continue the discussion.